if you run it, let me just show you. If you go through the steps in the slide, this is what you are formulating. You formulate this, okay, you formulate that using that same principle we had before. And X1 will be under this, X2 will be under that. If you watch carefully, and you are trying to formulate. If you follow my approach here, my approach here is quite complex. But if you are doing it actually, you're supposed to have them nicely organized. So you will have your, let me see if I can show you something. You will have your X1, X2, X3. It's making the noises there. Greater, you're disturbing. And you have initial values initialized to 0. And then the coefficient here will be 20,000, okay, 12,000, 9,000. And then your final Z value will be somewhere here, Z. And that will be a formula in there. And then under the X1, you are going to have 15,000 there. Okay, for the budget. You're going to have 6,000 for the budget, and then 4,000 for the budget. Then here at the top here, you will have your left-hand side, your sign, and then your right-hand side. Okay. And the value here is going to be less or equal to, then the right-hand side will be 100K. And then the rest will follow. So if you look at this second one here, it is 1 for the X1. So this one will be 1, this one will be 1, this one will be 1. Okay, and their values should be 4, 10, 7. Then there's a last one, which is 15. The 15 will be 1, 1, 1. Nicely organized. And once you've organized it like that, you can put it into Excel and you execute it. When you do that execution, boom, you get this final result, which will be your sensitivity range. So this is your sensitivity range. Let's ask some quick questions. Of course, the first question is always the evidential one, the easiest question. What is the optimal solution to this advertising problem? I need a hand for this. What is the optimal solution to this advertising problem? These are quick, because you get it by now. What is the optimal solution to this advertising problem? Optimal solution. Okay. Optimal solution. Yes, beauty. Dorothy.
The optimal solution will be doing 1.82 TV commercials, 10 radio commercials, and 3.182 newspaper ads.
Very good. So these are commercials. Now, from quickly on top of your head, you will notice that these are not supposed to be decimals because the number of TV commercials are supposed to be, real numbers, but there are decimals here. So you will later learn in integer programming. Next time, you will learn in integer programming how to make this an integer, a positive whole number. Okay, but I'll show you first how to model an integer programming problem. But for now, we leave it as it is, 1.8, 3.18, and then 10. So that's the optimal solution. What is the corresponding objective function value? To get the corresponding objective function value, what do you do? Who can tell me very quickly? These are easy ones. What is a corresponding objective function value? How do you work it? Don't give me the answer, but tell me, how do you work it? What is a corresponding number of exposure? Correct.
You multiply the final value of each by the objective coefficient, and then you add them together. As in for TV commercial. Okay.
So you take this one, you multiply this one by the 20,000. And then you multiply the 10 by the 12,000, the 3.18 by the 9,000, and then you sum all. And that will be your corresponding total number of exposure. Okay, so take note of that. The next question. What is the sensitivity range for the number of people reached by TV? What is the sensitivity range for the number of people reached by TV? Now, this is TV, the first one. Okay, that's TV. The number of people reached by TV, as you can see, is the final value. Is the 20,000. Okay. Is the 20,000. So when you look at this 20,000, come on. When you look at the 20,000, you are now going to take that 20,000 and find the lower bound and then the upper bound. The lower bound of the 20,000 is going to be 20,000 minus 11,000, which will give you 9,000. Okay, so that's the lower bound. The sensitivity for TV. Then the upper bound. The upper bound will be the 20,000 minus, the upper bound will be the 20,000 plus the 5,500. And that will be 25,500. Okay. So the sensitivity range for TV commercials is you want to be able to reach between 9,000 and 25,500 people. Currently, you are reaching 20,000 people. What does that mean? It means that as long as you increase your exposure, or your exposure dances between 9,000 and 25,500, as long as it is within that sensitivity range, the optimal solution of these three elements will not change. The optimal solution will remain as it is, as long as you are within the sensitivity range. Okay. The second thing is that if we're to find the sensitivity range for radio, watch for radio, okay, the lower bound will be 12,000 minus 1,000. So that will give you 11,000 for radio. And then, so sensitivity for radio will be sensitivity for radio. The lower bound will be 11,000. The upper bound is infinity, as you can see. So it will be 12,000 plus infinity, which is positive infinity. So what it means is that your radio can reach as many people as you can, but you should not come below 11,000 people. And as long as that is happening, your optimal solution of 10 radio commercials will not change. In fact, the optimal solution of 10 radio commercial and 3.18 newspaper ad and 1.8 TV commercials, all of them, that optimal solution will not change. So you should note that. So that is a key point that you have to note regarding this sensitivity. Again, you can see that it's the same sort of questioning that keeps coming up there. And the solution is right here. So I've done that for you right here. Now, of course, you should know that even though the optimal solution will not change, the profit will change. The profit, in this case, the total number of audience reached will change. It will change, even though the optimal solution will not change. When you come to the constraint, you can use the same principle to find the sensitivity range for the constraint, okay? But you should know that for the constraint, the optimal solution will change and the Z function, the Z objective value will also change. We've said this multiple times. Okay. Now let me ask you a tricky question. If BDSC, if they could raise actual radio commercial, watch the word, actual radio commercial, would that increase the number of audience reached? Where is the actual radio commercial? This is it. That's the actual radio commercial. If they should raise the actual radio commercial, the question is, would that raise the number of audience reached? Who can tell me? Would that increase the number of audience? That's a very simple question. Would that increase the number of audience if they should raise the radio commercial? Suppose they should increase the radio commercial from 10 to 11. Kwesi?
Yes, sir. For each unit increase, it would also increase by 1,000. The audience would increase by 1,000.
What if they raise the radio commercial by 10?
So that would be the shadow price times 10. Which will be 10,000.
Excellent. Very good. You understand. And I love it when you understand. Okay, all of you, which constraints are binding? Which constraints are binding? Please note that the constraints have got numbers. H4, H5, H6, H7, H8. Which constraints are binding? Obaya.
Okay, so H5, H7, and H8 are binding.
Good. Good. That's it. They are binding constraints. Now, which will BDC choose? Raising the actual radio by 500 or raising the actual TV by 500 or raising the actual radio by 2 commercials. So TV by 500, radio by 2. So TV has been increased by more, 500. Radio has been increased by 2. Which do you think the company is going to select? And of course, why?
The company is
Correct.
going to select radio.
Correct.
Radio.
Explain. Correct.
Because the shadow price for radio is 1,000, and that will help the company make more money than that of the TV, because TV, the shadow price for TV.
Not more money, but more people. They will reach more people.
More people, sorry. 2,000.
Yes. So 2,000 people will be added if they should go with the radio. Even if they increase the advert for TV by 500 different adverts, 500 different commercials, it won't reach any audience. It's not enough to reach the audience they want. Okay, next one. Look at the shadow price, the actual shadow price. Okay. And the shadow price of 5,000. Oh, no, let me take the shadow price of radio, 1,000. What does that mean? What does 1,000 radio shadow price mean? I want your personal understanding. The shadow price of 1,000. What does that really mean? Beauty. Yes, Sefako.
Okay, please. My own understanding means that one increase of advertisements will reach 1,000 people. Please, the screen has changed. Will reach 1,000 people, 1,000 people more. So one unit, if you add one more advert to what you already have, that means you're going to get—
Which advert? This specific.
Radio commercial, sorry. If you do one more radio commercial, you are going to reach 1,000 more people.
That's it. That's it.
Okay. Thank you.
That's it. So it really pays very well to do radio commercial. But of course, if you combine all of them, both radio, TV, and newspaper, that one is much better because that one will give you much more audience you reach. 5,000 more audience can be reached by just doing one of each. One of each. you'll reach 5,000 people. So that is how you capture this. Okay, you should be able to learn how to calculate all sensitivity. Okay. The last one for today is this question. Suppose we increase the number of audience reading newspaper by 220. 220, that's a question. We increase the newspaper audience by 220. Is that feasible? Let's answer that first. Is that feasible? Newspaper, we increase it by 220. Is that feasible and why? Is that feasible and why? This one, you got to be incredibly great to answer this. Is that feasible and why? You are increasing the newspaper by, see, saying no or yes is irrelevant. What is relevant is the why. Is that feasible? Say a Safako.
No.
Please, it's not feasible, because even when you increase it, if you increase newspaper ad by 1, you still not
From
reach
what?
anybody.
From what?
From 7, sorry.
Yeah.
From 7, if you increase newspaper from 7 to even 1, you still reach nobody because of the shadow price. It says that a little increase or one more advert will still not reach anybody. So if you increase it by 220, you will still not reach anybody.
Sensible answer. Very good. Love that.
Thank you.
Okay. So that is how it is. Now let's go. What impact will this have on the current value of the optimal solution? How would that affect the overall number of people reached? Regarding the overall number of people reached, we've seen that it will not do anything because of the shadow price. But what will it do to the current number of optimal solution? What will it do? Oh, by the way, if you like, you should go and look at it in your Excel. Just go and increase it by 220, and you will see that the optimal solution, what will happen to it? You will notice it. What will happen to the optimal solution? Could the optimal solution rearrange itself and still give us no change in the objective function value? Or the optimal solution will have to remain as it is? Go find out. Yes, Princess. Yes, Princess, yeah, your hand is up.
When
You sound very far away.
The right hand side. Sorry, please, can you hear me?
Yes.
Yeah, the ultimate solution will not change because here the shadow price is 0 with the newspaper. So the ultimate solution will not change, even if you add how many to it.
Have you tried it?
Maybe.
Have you tried it?
Let me try it.
Well, you can only try it if you have the Excel in front of you. All you got to do is to just take this 7 and then change that value of 7. Are we increasing it by or 2? Okay, by. So you increase the 7, add 220 to the 7. So you have 227. Okay, once you have 227, then you run the entire model again. And then check what happens to the profit and the audience, the number of audience reached. By the shadow price.
Change.
Sorry?
It won't change.
By the shadow price, nothing will change in the audience rate. Yeah. Then you can check what also happens to the final value. Have you done it before? You said it won't change.
I've not done it, but
I think you should do it first.
Okay.
Okay, you should do it first. That's one of the things I would encourage you all to go and do. I will also encourage you all to go and calculate the sensitivity range for each one of them. Okay. And I think there's one more thing that I've said you should go and check. Okay. So do that and confirm whether if a shadow price, a zero shadow price, will not be affected. A zero shadow price, when there's any change in the right answer value of a zero shadow price, we know that the objective function value will not change, but what happens to the optimal solution? So you can confirm that with yourself. All right, ladies and gentlemen, that brings us to the end of the entire caboodle. Yes, Sefako.
Sir, please, a question. Please, can you use the sensitivity range to know whether the optimal solution will change or not?
No, you cannot. For the constraint, you cannot use that. But right, for the variable cells, you can use that. You can use the sensitivity range to determine.
All right, thank you.
All right. That is why I told her to go and calculate and confirm. So that shows that you are listening. For you to ask that question means that you are really following. So next time we meet, what we are going to do is that we're going to look at integer programming problem. Okay, because you could see that when we looked at this, the solutions were decimals. So how do you handle decimals? You cannot just round them. You have to deal with them effectively. Then again, we've seen the practical application of linear programming. I will encourage you to look at the other practical ones in the book. At this stage, you will now have your assignment, the group assignment. And then you can do that group assignment, and then you'll submit. Everything will be sent to you in your Sakai as well as in your page. And then you will have 2 weeks, and then you can now submit it in 2 weeks. I know some of you have already started, so it's doing very well. All right, any question?